Hello, this is Fall 2013 Exam 5, Question 2, another Berquist-Sherman method question. It goes as given the following, then we're given the cumulative closed claim counts, and then we're given the cumulative paid claims, and then we're also given the ultimate claim counts. Assuming no further development for 48 months, and then they want us to use the BS paid adjustment to get the paid claim development, and then estimate the ultimate claims for AY 2012. All right, so for this one, we're going to need to use disposal rates because it is that BS paid claim development technique or paid adjustment technique. So that's the first thing that we will do, disposal rates. So I'm just gonna copy this guy down here. And if you notice, there's some black block to the right here. Yeah, that's my last attempt. You can ignore that. A lot of these questions are my second time through. So disposal rates are going to be the cumulative claim counts divided by that ultimate. I'm going to lock this in so it's easier to drag across. Nice. And then once you have the disposal rates, I'm just going to make a note that selected the latest diagonal. And diagonal. If you are using the frequency severity technique, you'll want to take an average of the disposal rates because this is the BS method. They typically want us to use the latest diagonal, and they do that because if we use the latest diagonal of disposal rates, we get to keep these cumulative paid adjusted amounts constant, or they don't change. So the next step is to calculate that adjusted paid claim. So once we have the disposal rates, we need to see if the paids are going up or down depending on the disposal rates. And typically, if the disposal rate is higher than the selected, so here we have 0.25 is selected, 0.5 is our actual disposal rate for 2009 at the 12-month period. Because this is higher, what that means is this value for the first paid is going to decrease. So this 2000, that needs to come down because its disposal rate is too high. Too much was disposed of at one time. And notice that it does decrease, and this is a sign that we should be using the BS technique. So this formula, because disposal rates are higher, we want to use linear interpolation between the past rate, which is 0, and the current amount. And then we'll multiply that by the disposal rate. Disposal rate is always on top in this equation. Disposal rate minus something, which in this case is 0 divided by, and then another note is that the bottom is always going to have our actual disposal rate minus whatever that new one is. And this will flip depending on what you have. For example, if the disposal rate was smaller, like say 0.2, that means we'd be using this 0.8 disposal rate. So we 0.8 minus 0.5. Because it's bigger, we use 0.5 minus the one disposal rate that's lower, which in this case is 0 because we don't have one that is lower. And then I'm going to lock in this cell. And luckily the others are all same, meaning there is no adjustment, 0.8, 0.8, 0.9, 0.9. So we can just drag it to diagonal as is, the rest such. All right, so once we get the paid, all we need to do now is get the paid loss development factors. So what that is we're going to take this guy here, paste it in, get the years. And actually, we don't need 2012, and we don't need 48 because loss development factors don't move like that. So we get 12, 24, we got 24 to 36, and 36, and the 36 to 48 period. And now this is the same as the chain ladder method. Just going to run through it real fast. Gotta go through here, drag the formulas down, and then I'm just going to take a straight average. I mean, after the adjustment, it looks like, oh, let's have a negative sign for me. I do. So after the adjustment, yeah, these are fairly close to each other. That's good. And then we get the select age to age to ultimate factor, which is the product of age to age. And really we only need the 12 to 24. That's because they want us to calculate the X in their 2012 ultimate claims. So AY 2012 claims. All that is the paid claims times that age to ultimate factor. And that is our answer.